your thickness. What is the thickness? Thickness of your leg of angle equal 1/2. This one, thickness of one leg. This one, diameter of the final hole. This one, because we have two holes. So you can get your area net. Your area net will be 5.77 minus 2 pi. 6/8, 3/4. 5.5. 5.02, that's right?
Yes, sir.
Hey, your area effective equal U time area net. That's right? U equal 1 minus x bar divide L. 1 minus x bar for this angle from table, or maybe it's given, equal 1.67 divided by L. Your distance from centroid of this hole to the first, to the edge of your member, 3 plus 3, most of the time the remaining distance is half this distance, 1.5. You can assume it. So 3 plus 3 plus 1.5, 7.5. Your factor U equal .77 or 0.78, something around 0.8, 0.85, 80%, 85%. So your area effective will be 0.78 times area net 5.02 equal 3.9 inch square. This value is the actual effective area of this angle will work if you design 0.75 F ultimate area effective. This gross area will be work if you design 0.9 F yield area gross. Any question? What will happen if you have welded connection? What will be the difference?
There's no loss.
Yes, 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 yes. Area gross equal area net, 5.77. This is the only difference. We don't have area net. We don't have hole. Your area gross is the same like area net. Your area effective equal U times area net. U 1 minus x bar divide L. 1 minus x bar 1.67, the same value. Your L is the distance between start of welding to the edge of your member is given 5.5 inch. You can get your factor. Something around 0.71, 0.72. So your area effective is equal 0.71 times 5.77. You can get your effective area. The only difference between bolted connection and welded connection, only one difference. Bolted connection, we need to look for what is the area net equal area gross minus subtraction. For the welded connection, area gross is the same like area net. We don't have holes. To summarize what we did,
the
will.
placement of the bolts, like, say up and down on the beam not matter, or?
Say it again?
So like, say, that example where you've got the 2 rows of bolts. like,
Yeah.
Say you only have one of those rows and they weren't centered, does that not factor into it, or are we just not going to that?
Many factors affect how to choose the arrangement of your bolts. First factor, how many bolts do you have? And this leg has a distance. If you put your holes, we have minimum distance. This distance between this center and the edge, we have a limit. We cannot exceed this limit. So sometimes I cannot put 2 rows like this. So the best way, I will move it a little bit up, and the second one here, and the third one here. Staggered. Sometimes your angle leg has a wide distance. Allow me to add 2 rows like this. When we are talking about connection, how many bolts, we will talk about what is the limit between edge of your leg and the center line for the first hole. What is the minimum or the limit between the edge of your member and the center line of your hole? We will talk about all of this stuff, but after exam 1. We are talking right now about the member itself. We just talk a little bit about connection. Your connection is ready, is given. But later, we will construct this connection exactly. Anyway, to summarize our design, according to LRFD, we have 2 requirements, actually 3 requirements. The first requirement, to avoid any yielding. We are talking about area gross and F yield and your factor of safety 0.9. The second requirement, to avoid fracture, we are talking about effective area of your cross section and ultimate strength. There is a third requirement, but this requirement related to your construction. Construction stage. When you are fabricating your truss, we would like R greater than or equal L here in the member length. Member length divide 300 R called radius of gyration. Radius of gyration is a section properties. Which one, Rx or Iy? Because we have 2 R. In your table, actually the minimum one. I'm not sure Rx or Ry, the smallest one. So mainly, we would like to focus only on these 2 requirements for design. But this one, to avoid any buckling in your member during construction. I know your member is under tension. We cannot expect buckling. But I'm talking about construction stage. We don't know what will happen during your construction, during your fabrication. So we would like your radius of gyration greater than or equal L divide 300. Anybody, did you hear before about radius of gyration? I believe you did. No, I believe you did. Did you hear about Ix?
Yes.
B H cubed divide 12. Did you hear about Iy? H B cubed divide 12. That's right? We have another Rx equal square root for I capital X divide N. This one called radius of gyration is very important in buckling. If you are trying to buckle a member, the section properties that support or resist this buckling called radius of gyration. We have another term, Ry equals square root I capital Y divide area. We don't care about this one because Rx and Ry are given in tables. But I'm talking about the concept. Anyway. Last example. We have 2 minutes. So right now, this one is the actual design, actual example that you need to do during your homework.
Just the other example.
The same.
You skip.
No, previous one. Something I skipped. It's not the time, the perfect time right now. Anyway, for this one, select an equal leg angle. Wow, we are looking what is the angle you need to use in this member. Size of your angle not given. But the member length 15 feet. The length of your member 15 feet. Your dead load equal 35 kb. Your live load 70 kb. Nothing else. So if you would like to get your design load, I'm sorry, not design load, factored load, B ultimate equal 1.2 dead load plus 1.6 live load. Second combination most of the time govern your design. So 1.2 time dead load 35 plus 1.6 time live load 70, you can get your factored load.
154.
154 kb. By the way, this value should be come from RISA 2D. From RISA, RISA can tell you what is the maximum combination value, what is the maximum effect in your member. So maximum tension force in my member from RISA 154 kb. I would like to design this member. Anyway, first step, P ultimate must less than or equal 0.9 time F yield time area gross. For minimum, I will assume B ultimate equal area gross. B ultimate, I know B ultimate, 154 equal 0.9. What is the F yield? Your steel 36, so F yield 36, that's right?
6.
F yield, steel A 36, that means F yield equal 36, F ultimate equal 58, KSI from table. Time area gross. I don't know what is the area gross of my angle. I think I can figure out what is the area gross. That's right? What's the value of area gross? 154 divide 4.75 inch square. Also, for construction stage, your radius of gyration must be greater than or equal, that's right, L divide 300. Just for construction stage, not related to any design. So I think we can assume R equal L divide 300. Your L equal 15 feet time 12 to be an inch divide 300. What is the value of R? 15 times 12 divide 300. 0.6. That's right? We also know B ultimate smaller or equal to 0.75 F ultimate area effective. So I will assume B ultimate equal 0.75 F ultimate area effective. So B ultimate 154 equal 0.75 times 58 times area effective. What is the value of area effective? What's the value?
$3.54.
2 point
3.54.
inches square.
It's 3.54.
3.54. Your table can give you what is the area gross, what is the value of R, but your table cannot give you area effective. So open your table. Let's start from the beginning. What is the area? Here you go. Here is your area gross. What you are looking for? I'm looking for area gross equal 4.75. Oh, 4.75 for 7.5. Yeah, something here, around here. 4.75. Do you think this one 4.38? No, this one not working. Maybe you can go up. Maybe you can change your page. Go down.
5.5.
More. 4.75. Yes. What do you think about this one? 4.75. If you choose 4.75 or above, that's correct. Do you remember my sentence? There is nothing wrong in design, but there is economic and uneconomic solution. If you choose not 4.75, if you choose 5.88, that's fine.